In this section 5.3, nonlinear systems of equations. Nonlinear means it's not a straight line. So all the stuff we've done earlier was straight lines. Here we have nonlinear, so we're going to see quadratics and things like that. How do we solve nonlinear system of equations? So that's the main question we're going to answer in this section. How to solve a system of equations. System of equations. Actually, let's write nonlinear equation. Nonlinear equations. That's the question we're going to answer. And really the best way, one of the easiest way, we use the substitution method. We use the substitution method to solve the systems. Let's say we need to solve system like y equals x squared minus 1. As you can see, that's not non-linear. And then, but the other one is linear, the other equation, but still this considered non-linear system of equations. So the easiest way, as I said or mentioned, substitution would be almost always the easiest way. So if we take, we substitute y equals x squared minus 1 into the second equation. So keep x the same, and the y, I'm going to replace it with x squared minus 1 equals 5. Then how are we going to solve this? I see quadratic. Always, when you see quadratic equations, we need to bring everything to one side and set it equal to 0. So I rewrote it this way. Subtract 5 on both sides. And we get x squared plus x minus 6 equals to 0. How you solve this equation? That's a quadratic, so we try to factor it out. And if it doesn't work, we use quadratic formula. X squared xx plus 3 minus 2 will do it. And to finish this kind of equations, solving this kind of equations, we set the first one equals 0 or the second one equals 0. Subtract 3 on both sides, add 2 on both sides. So I got the x values. That's not done. Remember when they say solve for x, solve this system means what is x and what is y. Now, where do I substitute the y values? You can substitute in the first one or second one. Let's say I want to substitute in the first one. Y equals x squared minus 5. Substitute negative 3. Remember, x squared means the whole x being squared. Minus 5. And that gives us 9 minus 5, which is 4. So I got the y value. For this one, same thing. Let's write the equation again. Y equals x is 2 squared minus 5. 2 squared is 2 times 2, 4 minus 5. That gives us negative 1. So in this case, this means I got two solutions. We got two solutions. Oh wait, that was minus 1. This was minus 1. Let's fix that out. Was minus 1. This was 1. See, I always check if when I'm done with the work. So this is 8 and this is 3. So for when x was negative 3, I got y equals 8. And when x was 2, I got y 3. These are the solutions. So these two equations, if we do them, graph them graphically, what it means, let's say that's the graph, the first one, because it's a parabola, opens upward, and the other one is a straight line. It's a straight line that possibly might go like this. So this is one of the points, and that's the other point. So I'm expecting this to be 2, 3, and this is negative 3, 8. That's what graphically it means. We are going to focus mostly on algebraically how to solve such equations or system of equations algebraically. Let's look at another example. Y equals negative x squared plus 2x plus 5, and y equals the absolute value of 2x. See, none of them is linear. So when I see non-linear system of equations, I always think about by substitution, to solve something like this by substitution. So I can substitute absolute value of x, 2x in there. So we use substitution method. So that gives me the absolute value of 2x equals negative x squared plus 2x plus 5. And now, what happens? How am I going to solve an equation has absolute value? By the definition of absolute value, it could be positive or negative, it depending on x. So I'm going to have two cases here to work with. One case when x is positive and case when x is negative. Okay, when x is positive, we can drop the absolute value and make it just positive 2x. And that would equal the equation on the right side, or the expression on the right side. If it's negative, that would give me negative 2x and keep the one on the right side the same. Now I get two separate equations that I have to deal with. I have to solve them. But keep an eye on this. Whatever answer we got here, if x is less than 0, we do not take it. And the same thing here. If x is bigger than 0, we do not take it. It's not considered a solution. So how do we finish solving this kind of equations? I see it's quadratic, means I need to add x squared to both sides, subtract 2x on both sides, and then subtract 5 on both sides, because I want to get everything to the left side. All these are gone. X squared, these cancel, minus 5 equals to 0. And now when I solve this, I add 5 to both sides. And if you remember what we call the square root property, it says if x squared equals a number, x is plus or minus the square root of that number. Always what this means, plus or minus, means one case positive and one case negative. But again, keep an eye on the highlighted part. See the x? X must be bigger than 0. So this doesn't work out. Only this works out. So I got the x value, okay, for this one. And now to find the y value for this, remember y equals the absolute value of 2x. That's the easiest place to substitute that in. So y equals the absolute value of 2 square root of 5, as you can see. And then because it's the square root of 5 and this is positive, so you can drop the absolute value. So one of the solutions is the square root of 5 comma 2 square root of 5. So we got the first one. What about the second one? Again, we're going to add x squared to both sides. We're going to subtract 2x on both sides. And we're going to subtract 5 on both sides. All this is gone, 0 here. We got x squared minus 4x minus 5. We got a quadratic equation that we need to solve. So how do we solve such quadratic equation? By factoring. So we get x minus 5 plus 1. We set this equal to 0, and we set this equal to 0. We get x equals 5, or x equals negative 1. I boxed both of them, but I need to go back up. Hey, only take x when it's negative. This is not negative. So I only take x equals negative 1. To get their corresponding y value, I can use this. Y equals 2 times negative 1. Y equals the absolute value of negative 2, which is positive 2. So then the solution is negative 1 comma 2. That's the other solution. So we get these two solutions. So if you graph the absolute value graphically, it means the absolute value is going to go like this, and that function maybe is going to go like that. So that's where the 2 points, or the two solutions. Let's look at another one similar to this. Solve y equals 2 absolute value of x minus 1 and y equals x squared. So how do we solve equations in this form? Well, let's see. Substitution is the easiest. We use the substitution method. We use the substitution method. So we set y equals y. So this means x squared equals 2 absolute value of x minus 1. Now I see an absolute value here. Again, split it into two cases. One case when x is positive, one case when x is negative. So let's see what we do here. When x is positive, it's going to become positive 2x minus 1. If x is negative, negative 2x minus 1. So again, keep an eye on these two conditions here. Let's see what we get. It's a quadratic, so I'm going to subtract 2x on both sides and add 1 to both sides. Quadratic again, add 2x on both sides, add 1 on both sides. Here I'm going to factor. Let's see what we get. X minus 1 will do it. Here we factor. X plus 1 will do it. So what do we get? X minus 1 is 0, x equals 1. X plus 1 is 0, x equals negative 1. So the two factors are the same. We don't have to repeat them twice. Let's see. In the first one, x must be positive, so this is okay. In the second one, x must be negative, so that's okay. Don't forget to find the corresponding y values. Y was the x squared. Let's take the x squared. So if you substitute y equals 1 here, 1 squared is 1. So the solution becomes x1, y1. And here, y equals x squared. Y equals negative 1 squared. When you square negative 1 is 1. So negative 1 comma 1. That's the other one. So we got two solutions here. Two solutions. Let's look at a different one. A different kind of problem. Maybe x squared y cubed equals 10 to the 23rd power. X to the 4th over y squared equals 10 to the 6th power. We cannot use calculators, so let's see what we are going to do here. There's many ways to solve this, many ways. So let's say I'm going to start with solving, taking the second equation. Different people approach it differently, and we don't like to see fractions, so I'm going to multiply by y squared. So x to the 4th is 10 to the 6th y squared. Now, no fractions. We have no fractions. Maybe we can substitute this into the first equation. Can we substitute this into the first? Well, let's see. I don't have x to the 4th in the second equation. So what I'm going to do, I have this as the first equation. To make this x to the 4th, we can raise both sides to the second power. Like so. Let's see what we get. X to the 4th, y to the 6th, because you multiply. 10 to the 46. Now I can substitute this in here. X to the 4th is 10 to the 6th y squared, and y to the 6th stays the same, is 10 to the 46. We can divide both sides 10 to the 6th to eliminate the y's. These are gone. Here we got y to the 8th equals 10 to the 46 minus 6 is 40. How do I get y? Well, I raise both sides. We raise both sides to 1 over 8. 1 over 8, because this cancels now. So you got y equals 40 times 1 over 8 is 5. And you don't have to write the whole thing down. Just like that. Y equals x to the 10 to the 4th power. Now, we can go back to either one of the equations and get the y value. Let's say I can use this equation if I like to. X to the 4th equals 10 to the 6th. X to the 4th is 10 to the 6th y squared. Let's see what we do here. We substitute the y value we obtained, which was 10 to the 5th, all raised to the second power. This stays the same. Multiply the 5 times 2 is 10. So I have x to the 4th is 10 to the 16. Again, as we did earlier, we can raise both sides to the 1 over 4 power, because I want to get x by itself, 1 to the 4th. So that means x by itself equals 16 divided by 4 is 4. So the solution would be, the xy would be 10 to the 4th, and y was 10 to the 5th. That's what this section is about. It's about learning how to solve nonlinear system of equations. It could be like a straight line with a parabola. It could be an absolute value with a parabola. It could be an absolute value with a straight line, as long as the two equations are not both linear. It could be one linear and the other one is non, or could both of them be nonlinear. But notice in almost all of them, we had the quadratic. We had like x squared in there involved. Just the last example was both nonlinear, but then we had like x squared and y to the third, like different exponents. And just the idea behind this is the trick for using the substitution method and the properties of exponents.